Welcome everyone to today's ESIP Semantic Tech webinar. Today we have the honor to have Professor Jim Ogg from Purdue University to give us a talk about plate tectonics, geovisualization, paleogeography, especially the work on the geonex.org, very recent work on how to using vocabulary database technologies to digitize a lot of those heterogeneous terminology in stratigraphy. To save time, normally we'll skip the detailed introduction. So Jim, I will give the floor to you. You can have more time for your talk.
Okay.
Thanks a lot.
I'll go to share screen here. Okay, you should see just the slide at this point.
Yep.
So this would probably be a different topic for some of you, and for some of you, it'd be something you know very well, and that is about geological formations on the planet, and essentially, what are they, and then where were they in the past? And so this is a presentation on behalf of a very large group. I'm showing just some of the computer engineering students and geologists that I work with around the world. So this essentially the whole project is only possible because the computer engineers to make the display systems and then the geologists to populate it with the information. So myself, I'm a mixed paleomagnetics, which is the ancient Earth history of the field reversals and how to use it for correlation. Ocean drilling program, I participated in several cruises on that in the past. And then this led to integrated timescales, putting together sea level changes, changes in evolution of life, the climate, and then geological formations, which is part of what I do today. And part of this was associated with the International Stratigraphic Commission. So there was a conference, 2019, of different geological organizations around the world to come together and say, it would be great if we have a database system and tools to better understand our planet's history, the entire past 4 billion of years of it, and represented all different specialties. And I was associated with one group. I originally came in for the time scale, but then because the people with the paleogeography, they were a little unsure of their English, they asked me to present the paleogeography, and that's what led to this program. So here are some names of units of geological rocks in different parts of the world. I challenge any of you to tell me where they are, what they are, and when they are, plus what's above and below. This is a common problem in handling geological literature. There are 10,000, 20,000 names in just written in English, and many, of course, written in the local languages. So the goal of the lexicon is like a dictionary of these, is a database of these geological formations and a summary, but also not just outcrops, but where in the world it was originally deposited. The Paleogeography Working Group of what became the Deep Time Digital Earth community, which is much larger than the paleogeography one, they put up a series of milestones or goals. The first one was to link existing databases, and you'll see some of that, which part of this lexicon project. And then all the geological formations in the entire world, it'd be great to have an understanding of what I just showed you, when, where, what they are. And then that led, of course, to knowledge trees and artificial intelligence and other aspects. And then to put together better paleogeographic atlases with this database of all the geological formations throughout Earth's history. And then get it to the public, because you want to make this accessible, not just to researchers, but to the general public as well, and for education. The first one we finished was a collaboration with India and Pakistan to show some of the people involved in that part of the world. And it was to put together all the geological formations of that region. Fortunately, they were already working to compile a publication which detailed all this information. And so we said, let's put the thing online and develop a system for it. So I'll show you how, what we call it's called INPLEX, or Indian Plate Lexicon, because it's India and Pakistan. The geologists work together, the politicians may not. Here, when you click open the lexicon for India Plate, you see a location map, and you can choose in the upper left an interval of time, and then you can click on a different region. And these are color-coded because it spans a couple countries in many cases, but the geology in that particular region is related to each other. So let's click on a region. What comes up is then for the time interval you have selected, it shows you the representative stratigraphic columns of the names of different geological formations, what's above and below them. And then the patterns are taken from a combination from the US Geological Survey and GeoArabia to then highlight in color and pattern what the rock types are, very simplistically. So if you see yellow there, it is sandy. If you see browns, it's clay. If you see blue, it's a type of limestone. If you see red, there's only one you see on the chart there. It's a volcanic material. And then we have a couple other colors for dolomites and so forth. And then if you click on one of these, then it takes you, it activates the database behind it. And the database then populates a website on the fly. These websites don't exist until you actually click on the formation, and generates the information to go with that geological formation. So you have the standard things of the name, the different geological period that it was deposited in, the age interval it spans, where it is as far as the province, in this case, the region in Pakistan or in India, how it got its name, what it consists of, what fossils are in it, and essentially the basic information that all these type of lexicons, as they call them, that put out by different countries contain. Because it's generated from a database, that means that what's above and below, it will automatically look for that name in the database and put in a hot link. So the blue that you see here, if you click on the one that's either above it or below it, then it will take you to that page, which shows you the information about that formation or group. We put in images. If you click on one of the small images, it opens a full-sized image, if it's provided by the geologists who work there. You can also do regular searches. You don't have to use this graphical interface that I showed you before. You can say, show me all the formations. The default is it puts them in order with time throughout the entire Indian plate. And so the color that you see here is the geological period that began in, using the standard international color for that geological period or stage within it. And so this is just a portion for the Jurassic in blue and the Triassic below. You can also do searches by, I want to see all the formations that are limestone, or I want to see all the formations that have coal, or I want to see only the formations in this province, any sort of filters you want to do. If you want to see them alphabetically, then you get like a Christmas tree comes up, and these are in alphabetical order. And the reason they're all in these different colors, it represents the stage, the geological age that it begins in. A similar project, I'll just show you a couple examples of these, we'll get shorter, was with Vietnam. So I went there to work with the Vietnam National University, and that led to an interesting feature. As opposed to the information available from India and Pakistan, in Vietnam, they also had the local language version for their geological formations. And so here, I have no idea exactly how to pronounce it with all those odd accent marks on it. What is written in English as the ESIP formation has these localized pronunciations and way that they type them in. I have no idea how to type that in the keyboard myself, but there, because we want to have it for the general public, you can put the name in the Vietnamese, and then it won't come up as the main formation, but checks within the synonyms and says, I couldn't find it as a main name, but here it is as a synonym. Click on that to get the information. And you can see down here at the bottom, it has a variety of other names that people have given it through time. So we also have that for in Thai language, and if it's provided in the Chinese language as well for those different countries. For China, there's a very large group that's been putting together an English version of all the geological formations of China. It's a very massive effort because there's approximately 3,500 formations in China. China is much more complicated because it consisted of all these separate blocks that came together through geological time. Their pictures that they show here tend to be ones when they're a little bit younger. Essentially, most of those people are now retired, and this is true in many parts of the world. The experts on the geological histories are retired, and so one has to sort of capture their information now, because quite often the newer ones coming in, it takes you essentially half a lifetime to get to the knowledge that these people have. So we've been working with the China Stratigraphic Commission. We put together a website, the China Lex, which has their initial draft. Last week came an update for the Ordovician, revising some of the information for that interval of time. I just showed this very briefly on the China one. Go to Xinjiang, and it brings you up on the typical one you saw before. All of our websites we've done with the countries have the same format and the same fields, which makes them, we can then search all of them at once, which I'll show you in a moment. Remember this name, the Yijiang formation? I'll show you a bit more on that later. This shows, because the different experts you saw on the first page, each of them specialize in a separate period of geological history. And it's about, what, 15 periods, I think, roughly. And they all have their reference columns for the geological formations and the location of that reference column to average out over an area. And this shows you, again, using the colors of the geological periods, the location of all of these hundreds of reference columns. That means it's separate columns that you saw in the display. Now, we can do more than just have the information come up as a web page in text. One we want to do is put this in paleogeography. In order to do that, we need to know not just here's a name for where the formation is located, but we need to know where was the original extent of it. In that case, one sits down with the experts on that area and that interval of time, and you twist their arm and you say, draw me on a map, where was this formation deposited to the best of your guess? So here is an expert for the Cretaceous working on a map, drawing where these things are located. So here was part of what he drew. In this case, it's for part of the Tibet region. So in here, here's where he thinks these different formations were. We can code that information as GeoLexicon. I'll show you, I'm sorry, GeoJSON. I'll show that in a moment. We did the same thing with the Vietnam. They're a little bit more generous in how much big an area they drew the original locations of the formations and the extent, in this case, of volcanism that occurred near one of the large fault areas. So we code up this information as a latitude, longitude polygon. We know the general lithology for the fill of that polygon. We use the same patterns you saw before on the stratigraphic columns. We know the age, and we can now take that information and say, here's where it is today. Now rotate this back on plate tectonic models into the past and show us where it was located and fill in that polygon with the pattern. So this one I had before, I said, remember this name? This shows on three different models that people have put out. One is the G-Plates default model. One is a continental flooding model from Norway. G-Plates is located more in Australia. And there's Chris Cotes in Chicago, who's much more artistic, imaginative. And that's the type of reconstructions you normally see in museums and in textbooks. And this displays for the appropriate time interval for each of these different models, where was this geological formation in Tibet, and fills it in with the pattern, which is limestone. And you can see, well, the G-plates ones, they don't put in where the shorelines were, unlike the ones in Norway, the continental flooding one. It fits the continental flooding one. Criscoteses, well, Criscoteses is kind of a timed average, so potentially, yes, it would fit. It's pretty close. It's right next to the shoreline there in his reconstructions. This is an enlargement, zooming in on Criscoteses one. We can do that for any of the geological formations where the people have provided, here is the original extent. One of our current projects is with Africa. We're only working in regions where there does not exist already an online lexicon. For Niger, there was a book that just came out on the stratigraphic lexicon of Niger. And so Jacques Leblanc contacted us and asked, can you put this one online? Niger is relatively simple. It's in the middle of Africa, and therefore it's been rather stable. And you have essentially the fill of basins through time. So I'm not going to go into much on the African one. I'm going to show you how do we then populate this online ones to do the ones like Niger or China and so forth. First, let's go to the general admin page for one of these websites. If you click on the admin login, you can then edit the information that's there. You can add in images. You can delete the formation, sort of the basic editing. This is not where you enter in new information. Instead, you go down to one that says parse Word document. On the right is one of these Word documents, and the computer system takes the Word file, just the straight Word file. It knows that, first, if it sees this asterisks, it's going to be another formation below it. If it sees the FM as the end of the line, and then it sees these different headers with the spaces in between, and it knows, yes, this header is a field in my database. I then populate it with the information that I see here that follows that header. And so it's very nice because people can put together the Word documents, and they can do spell checks and so forth, and you just upload it. And then the system tells you if you made an error, at least as far as some of the patterns or the ages are concerned, otherwise it accepts the information. If you want to replace it with new information, just upload it again, it replaces the previous. One part is the ages, the age span for geological formations. On the lower part in the left, what we put in is not a numerical age. We put in the geological age. Geology is split into about 100 different geological stages. Each period has about a dozen of those. And then the stage names is what we use, and the percent up as far as where the formation begins and where the formation ends, according to what the experts have provided us or the published lexicon information. Then the database itself says, I know these names of the formation of the stages. I know the percent up. I then go to a lookup table, the geological time scale, and then I take that information and then I decide what is then the numerical age. The nice part about that is that geological timescales are always being improved. The ages may change slightly on the beginnings and endings of some of the geological stages with better radiometric dating and cyclostratigraphy and other aspects. So we just load in a new geological timescale, and it redates every one of the geological formations in that entire database. Now, I've shown you a couple of the Niger, the Vietnam, the Indian plate, the China. So at a certain point we said, what we need to have is a general entry page now that then gives people access to all of those at the same time. And so this multi-country page, this is the GeoRef by itself. then a GeoLex, I made a mistake there, it's geolex.org. You can then type in a name of a formation. You can search all the countries at once, give you back here are the countries that have that formation name. The nice thing about the search is if you don't know exactly how to spell the entire name, you can put in part of it and it'll bring you back all the formations that contain that as part of the word. Or you can do a time slice and say, I want to see all the formations that were deposited, say, 400 million years ago or 70 million years ago. Bring all those back for all the countries that are in your current lexicon system. So here, we've entered in 66 million years ago. And I've said, I want to search all of the websites. Here are the formations that were deposited 66 million years ago on each one of the different regions, which are currently in this linked lexicon system. And then I want to display these onto a plate reconstruction. So this is just showing the portion for Niger. We don't have the rest of Africa yet, just Niger. That's where everything seems to end right there on the middle of the continent. And for India, Pakistan. And it shows you 66 million years ago over in India, Pakistan region, there's a big red area because there's a huge volcanic eruption called the Deccan Traps. Well, meanwhile, over in Niger, the western part of Niger is flooded by a shallow sea, which actually connects further across to Africa. And the eastern part is having a lot of deposits of sands and conglomerate and so forth. So you can do essentially here, at that time, what rocks were being deposited on our surface of the Earth at 66 million years ago. Let's take a look at another one, 70 million years ago. In this case, we're going to look more for the Asia set. So here, it shows you now China and Vietnam on 3 different reconstructions. You can show me all 3 at once. And it shows you the geological formations being deposited 70 million years ago, plotted on different people's models of what the world looked like 70 million years ago. And you notice that these don't coincide with each other. People have different locations for some of the small geological plates. And so you can see that, for example, here, put my mouse. In this case, in Criscoteses, this claystone was deposited next to this shallow sea. In the case of continental flooding, you see the orientation is completely different. Here it's east-west, here it's primarily north-south. The default by G-plates is essentially north-south as well. But you see here in the continental flooding one, there's active volcanism, which is now Vietnam, facing into the Pacific, whereas the G-plates model has as if there's another continental block sitting next to it. So you can then compare these different models, what was being deposited at that time, and how does it fit the different reconstructions. When you plot those, you would like to be able to go the other way, be able to click then on that reconstruction with all those different ones deposited and say, what is that place? What was the red one? What was the blue one? And so we have that. You can click then onto the reconstruction that comes back on your screen, and we'll go then to a little small window, give you basic information, and then to that appropriate lexicon. So you can go the other direction as well. Now, so the basic inputs we need to put one together for a country is first a word files, be a combination of word files because they can add together, of the geological information on each formation. We can check, we tell the people we'll format it ourselves. Don't worry about it. We just need the information. If it's in 2 languages, that's ideal. Figures and images make it even better for the general public and other geologists. So that's the part in blue there. And then we need to have a stratigraphic column that shows here is the age span and the generalized pattern to put into it to represent the rock type. We put in the standardized basis patterns. We have our nomenclature for the rock units for the patterns. And then probably the most challenging part to get from the geologist is not just where was this outcrop, but for that formation, what was the original area that it covered? For North America, we're not doing North America. because Macrostrat at the University of Wisconsin with Shannon Peters' group have put together a fantastic system of linking the geological maps of North America to the North American lexicons, Canada, and US Geological Survey. There's a little different interface. And so if you put in, show me the information on the Marcellus Formation. The Marcellus was deposited about 400 million years ago, and it is an organic rich deposit that is now being fracked to provide lots of natural gas in the Ohio, Pennsylvania region. And so when you put in Marcellus, what comes back, it's really hard to see on their website, is the location of the Marcellus Formation on the present-day Earth's surface. That is essentially what we need to have, the basic information, to then be able to put this onto the ancient Earth's surface. So we developed an interface with them, and likewise gave them information so they can interface with our lexicons. So we can take in a search for theirs and bring it in different way that we can handle it to do the display. And this involved very interesting challenge because their nomenclature for fields, even their names for rock units are completely different than the ones we've been using for other parts of the world. And this is like having to go to a different country and take your plug that you brought from the United States, and be able to plug it into the sockets over into Europe. So you need these converters. And so we built the converters and we gave them the other directions they can convert to ours. So it brings in then here for these different polygons. Here is the geological name, here's the lithology. And so now we can take the information on the Marcellus and we can put it onto the different plate models. And so on the left, you have the default model from the G plates with the continental positions. And on the right is the Chris Cotees version. You can see on the Chris Cotees version, it very dramatically shows that this Marcellus Formation, organic rich shale, was deposited in essentially the outer deltas coming out from these uplifted, what will become eventually the Appalachian Mountains of today, but they're much higher back then. One thing nice that Macrostrat has done is they've made theirs available on an app on your phone called RockD. And RockD, you can go out in the field or you can scan through things yourself at home, and it brings you up the geological map from the US Geological Survey. And then if you click on the map, it gives you the information on that geological unit from the US Geological Survey. That's the upper portion of what you see here on the right, and then their connection to their information they have on Macrostrat. So let's use the same thing. Ideally, if you were in Beijing, China, then the hills next to you are Precambrian in age. It would be nice if you could then click on the geological map, which is available, not yet on the phone, but at least it's available on the browser systems. Click on that, and then go to our lexicon entry to give you the information about that geological formation. So with this concept in mind, and having Macrostrat to choose as an example, I then went to the China Geological Survey and said, here is what you guys can do in collaboration with our lexicon. Realize the geological maps of China used to be classified, and now they've gone to open science, and now all the maps are available on the browser in the detail, and so likewise the geological information. So as a demo, they put together very fast for part of their geological map for southern China, South China, that you could then click on a region. This one is like this D2D, which you have no idea what it is. You click on that and says, this is the Rongxian Formation. And then it links into our lexicon to give you all the information you would ever want to know about the Rongxian Formation. Ideally, we would do the same thing with other geological maps. And this is a collaboration project we have with the Commission Geological Map of the World, which is part of UNESCO. That, for example, on Africa, right now, if you could click on the Niger Basin, that one that's up there in green that the arrow comes from, it would then bring up the stratigraphic column for that part of the Niger region. And you can then click on the individual formations to then give you the detail, essentially to make the entire geological map of the world interactive, the way that the North American one has become with MacroStrat. Now, the challenges, first, as you might guess, this takes a lot of work. There's 3,500 formations in China. There's probably 1,500 elsewhere we've entered or more. And just be able to put the information in organized fashion takes people. So far, that's part of the group I showed there at the beginning. And then once you put it up, what you would like to do is keep it updated. And that means experts, we should look at it and say, can you change this? Can you change that? That's really tricky, actually, to get the experts to send you the information they would like to have rather than just complaining, oh, you've got it all wrong on this formation. What we found out putting these together is that there's much disagreement in some cases on types of lithology in the formation, the spelling of the formation names, and other things. So we put in, if possible, the different opinions as well into the lexicon, not just one. We're not the first people to do this. Companies such as Halliburton have a database that you can pay lots and lots of money to be able to access to essentially ask the same questions that we want to put together for the lexicon. We've talked to them. The geologists agree it'd be nice to have all that information available because right now it's sort of hidden from the public view, unless you have this thousands and thousands of dollars subscription. And the geologists agree they'd like to do it. It's when they go to their business people and say, yes, but then why would people pay us for it anymore? So right now, essentially, we are continuing to have to do it ourselves with the geological surveys. And they want to make this visible to the public. That visible to the public challenge, we did change the way the websites were designed. What's it called? Mindat. I asked Mindat how they made theirs so accessible to Google searches. And they explained that instead of generating web pages on the fly, they generated the entire set of web pages and stored them on the cloud, enormous quantity of them. And therefore, the search engines can find them all in the cloud because they exist. We changed ours, so at least the search engines now, it looks as if there's a website and they go and search it and they come back. So as Marshall had showed me, yes, if you type into Google the name of the formation, I gave you the one we used before, that one is located in Tibet. And if you put the word Geolex after it, Google knows it exists and it comes back as the first thing on the search return. There's also a couple other papers it brings back. I have no idea where iridolite is. Sorry, it's one of these obscure terms. However, if you didn't have Geolex, you put in the name of the formation in China, it's as if we don't exist. So if you have some ideas how we can get Google and other search engines to know we exist for things like the name of the formation and the location, not having to put the Geolex, that would be great. Our current projects, Africa has almost no online geological lexicons. In fact, many places don't even have any published geological lexicons. So we're working with UNESCO and some of the national geological surveys to put together all of Africa. That will take us a couple of years probably to have it completely populated. We should have a simple version done, we hope, by the fall. The other countries that do have these online lexicons that we want to link to, like I showed with the MacroStrat interface into the US Geological Survey. One problem is that many of the national lexicons do not have the areal extent of formations, which means it's rather useless for paleogeography. So we have to talk to each one of them as whether they can give us that information, the region area they originally covered. I didn't show you, but we have fossils in the formations, and there are all these Latin names that no one's ever heard of. So now we're working with the Treatise of Invertebrate Paleontology to have an online database which will have the images of all the fossils, at least the genera. And so therefore it will be automatically linked. And so if you click on the lexicon, you click on the genera name, it will then show you a picture of what does that fossil look like. We're doing this with different parts of the world, geological surveys, stratigraphic commissions. Ideally, they would be hosted in the countries that provide the information. That's what we offer. We talk to India, talk to Vietnam about doing this, and China. So far, that seems to be, they're happy that we have it existing in the cloud. We're taking care of it, and we update it. We would like to have them take it over in the future. We do have the administration for them to be able to continuously update it. And then part of the fair, we have the findable, we have the accessible partly, and that's the interoperable and the reusable. And there we're thinking of taking all the Word files and making them available in GitHub, or I have a dump of the database as Excel so people can access it via the GitHub. The difficulty is every day we're changing these databases. So like revamping the Ordovician, we're putting new stuff for Africa. And so whatever we put on the GitHub is available is always going to be out of date. And then there's the open science part of it. We are putting the code be publicly available on the GitHub, along with explanations of the APIs, so that anyone can access the information in the lexicon, just like the MacroStrat can access ours with the APIs. So this is all, like I said, I thank all the people I work with because they're the ones that make it possible. All that magic you saw with the software and display, all that's done by the people in computer science, and all the graphics that you saw is essentially by Gabi, who's sitting next to me, did the interface graphics. And so the other ones then prefer the plate models and of course the basic information. This is just part of the people. I didn't want to cover the slide with lots of little tiny pictures. So thank you very much, and perhaps you might have some very good recommendations for us.
Yeah, again, thanks a lot, Jim, for this wonderful talk. We have plenty of time for comments and questions. Are there anyone from the audience?
I overwhelmed them.
Yeah.
So I have a question. Hello, my name's Daniel, and I actually work with MacroStrat, and I've worked with the EDI period in MacroStrat. So I'm curious, I'm sorry, I don't have recommendations for you because we encountered the same issues, right? And we've been trying to expand the footprint of MacroStrat and things like that. But I'm curious, some of the powers of MacroStrat is being able to create curves of rocks through time. And I was curious as if there's currently ways to say pool bulk data from GeoLex or GeoRef in terms of if I wanted a specific time period and I wanted to pool all the formations that intersect that time period, for instance. So I guess not having experience working with the tools you have, how do you best go about searching these if you wanted to find specific either rock types or ages or other things like that?
We can do a search if you want to with a slice of time, and it would bring you back the polygons and the names of the formations. And you could then, if you want to, like, I think the MacroStrat, they compared the aerial extent through time, right? So you could do that because you have the basic information coming back. The polygons, you would have to do the aerial conversion of the polygon. And then you know what it's filled with, the pattern name, which tends to be like claystone type of limestone. No one could do the same kind of extraction for other parts of the world. What we have in the lithology descriptions is the thicknesses, but then you take sort of thicknesses versus the time span. And then you can actually probably work out something kind of like the Russians have tried to do, accumulation rates through time. Thickness is not a separate field. It's part of the description because of the way that people often worded it. But it's all there. So one could presumably have some sort of AI know that, yes, I look for like meters and intelligent enough to say whether it's thickness or something appropriate to go with it. And then it has the age span available to you. So you could take that and then work out the accumulation rates for the information that people have provided. Realize each formation is going to be kind of thinning toward the edges and thicker in the center. So you'd have to have some adjustment for that. That's going to be a challenge regardless. MacroStrat has the same thing, right? Because your columns in MacroStrat is an average, for example, the northern part of Indiana all averaged together to give you one thickness to go with it. So it'll be an initial cut. You're welcome to it. Great. Go ahead. I urge you. Yes.
Yeah, that's fascinating. Thank you. I'll have to definitely dig around into these more.
Yeah, Harvey.
Harvey.
So Jim, first I want to thank you and all of the colleagues you have worked with. This is magnificent work that is so important. You know, we owe you so much. You deserve our respect and appreciation and admiration. So thank you. And next, I want to try to compose a question that somehow asks something like, if we had unlimited money to optimize these information systems worldwide over the next 10 years, what would we do? Maybe we're doing that already. Now, you mentioned that in the private sector, there are tremendous information resources. Well, I wish those people a happy life. You know, as you said, it is what it is, and they sell it, and we can't, you know, and so the public sector is the public sector, and we need to just go forward. I don't like to be told, no, don't do that, Harvey. Industry has done that already. Well, what am I supposed to do with that? So we need knowledge. We need good information. We want to solve the evolution of life. We want to solve the evolution of the planet. However, we also want sustainable energy for the population of the planet. We also want materials, critical minerals. We also want to protect groundwater. Once a month, if not twice, the New York Times declares that the USA has a national groundwater crisis because we're just groping blindly. So geology is just absolutely essential for for the well-being of every person on the planet. And the work that you showed us today is just fundamental to geology as a whole in relation to energy, minerals, water, and the well-being and sustainability of people and life forms on the planet. So what you do is really, really important. So I wish that you could tell us that these information systems are in great shape and they're stable and they're optimized, but I don't think that's the case. And so you gave us a talk today, and I think I understand it to a degree, but I can't fully visualize everything you talked about in terms of exactly the format of the information and what it's really defining. And so I'm working on clarifying what you talked about and how that links to geological maps, bearing in mind that a standard geological map is a conceptual model, not vertically georeferenced. And if we want to plan geothermal energy or model groundwater, we need to take a geological map and turn it into multiple layers with thicknesses. And so ideally, these various information systems fit together and they're stable, they're optimized such that we can plan the future of this planet. And what you described today was, you know, really, really impressive. And I found myself thinking, well, if this could be crowdsourced by authorized contributors, as you say, jurisdictional geological survey agencies almost have a duty to optimize these things. So you see where I'm just groping about, Jim. And if I could just go back to my original question, if we had unlimited money, we don't want too much money. One of the worst things that can happen to a person is they're given too much money. If you had just the right amount of money to do this very efficiently and simply, what would we do over the next 10 years?
The part about the money, what we need is the people. And so it's to compensate the people to make it worthwhile their time to do it. What I showed you with the computer engineering student, it's the undergrads I work with in computer engineering that make it possible. Undergrads in computer engineering, they've done all the magic. We hardly pay them at all. So that they enjoy it because they know the world's going to use it. If you had that kind of philosophy also with some of the companies said, yes, we sell the detailed information, but the generalized stuff we could release to the public. I've tried to talk to the Halliburton people and other ones. We're not interested in your details, all the wells and everything. We want just the average material, like the basin fill with time and so forth. And that's where the geologists seem happy, and then they go up the next level, and yeah, we run into problems. So I think probably what we need for the quote money is actually just a change in the philosophy of the companies, realizing that the bigger data sets, the average of it, the generalized stuff, would actually help their business, because you could sort of say, just like, Google makes a lot of things for free and they make money from the advertising. Essentially, it would be like they're advertising, it's available to the public. If you want more detail, then give us money. So that's what I kind of hope. The part also about people, the challenge is to get the experts in the local countries that know about it. And so I'm not sure if that's so much money, it's just to be able to make the contacts. Usually, once we show this to a country, like I go to Japan, show the Geological Survey, they get very excited about it. They want to have it, and they provide us the information. And so the expense is the people then to take the information and to code it. Usually the information is already available in a nice form, like MicroStrats is available, but you have to change the formatting and stuff like that to be able to use it. And it's something that I guess your whole committee is, yes, here's information. We want to be able to put it into different tool systems and have these converters, not standardize it necessarily, but at least to understand the formats, to be able to then take your plug and plug it into Europe, plug it into Japan, plug it into the United States, and it all works, right?
Thanks, Jim and Javi. Any other comments or questions? Yeah, Megan, do you have a question?
Yes, I had a kind of two questions, but very related to, I think, the conversation that you were already having. One, it sounds like you love working with the computer engineers and that you've had a very good experience. I guess I would ask, like, what do you think is the key to that? You mentioned that many of them are really passionate about kind of the end goal and this data getting out there and being used. But how do you kind of foster healthy relationships between geoscientists and computer scientists? And then the second question, very related, I think I heard you saying there are fewer stratigraphers these days, or maybe you were just saying the stratigraphers with the knowledge are getting more mature. But is that a problem? And if so, like, how do we encourage more people to go into the field of stratigraphy, for example?
So your latter one has been a topic at various geological organizations for a while as their membership kind of shrinks. For example, the paleontologists, the basic ones that pick up a fossil and tell you what age it is and what it is. There are fewer and fewer of those because most students are not so interested in going to look at the rocks and stuff. They prefer the computer screens. And so you have this, like if you have an ammonite, you know what ammonites are? There's these fossils with the curls. If you have an ammonite right now in the United States and you want to have identified, good luck. There is not essentially an ammonite person left in the United States to give you identification. That's how bad it is right now. The same thing's happening over in Europe. I have a colleague in Great Britain. He seems to be like the last one there, which used to be a community. So there's a whole body of knowledge that you want to have it captured. The new students, they're not so interested in it, it seems. It's hard to attract them. And part of that you can blame upon industry. It used to be that oil companies would all of us have people that use the fossils to tell them what age it is. And now they don't. They pretty much have cut back their departments on that. That's also true for the regional stratigraphy, the mapping geologists and so forth. You've talked to U.S. Geological Survey, just their funds that they have to do improve geological mapping is more and more limited. So, and states as well. there's no easy solution there, except maybe to make the public more aware of, here, this is something really interesting. And this is what you would learn about the earth and what's under your feet. And we should really support
Yeah.
this. Yes.
And we just doubled the budget. The National
Like that.
Cooperative
If you
Geologic.
double the budget, you can't even get Congress to agree on a budget, period. Yes.
What? We got more money than we know what to do with.
Okay.
The geological mapping budget has increased from 24 million a year to 44 million per year from FY19 to FY23. So the geological mapping budget has doubled. We added $64 million per year for geophysical surveys. You know, the budget for geological mapping is escalating. And I know because I did it.
Thank you. Wow. Okay. 'Cause I know
You're
before it had
welcome.
been going down continuously. All right.
No, it never went down, but it was very, very stagnant for many years. But now we've doubled our money.
So do you think they could apply that internationally as well as to North America?
Short answer is no. So sorry I interrupted, but you know,
Okay.
we've corrected the issue with the geological mapping budget. And I just submitted FY25 appropriation requests to Congress this morning. You know, we're on top of this. If you need more money, let's just go get it.
Okay, it'd be great to do that on the international level, because the Commission Geological Map of the World, they're down to 2 people essentially funded. That's Geological Map of the World, right? Yes. So
That's a
rest
very
of
good point. And
volunteers.
DDE was crucial for supporting CGMW in what is truly astounding work. So I may have interrupted, but may I just continue interrupting?
Sure.
Yeah, go ahead.
Marshall, how much time? When are you going to shut this down, Marshall?
We have 5 minutes.
5 minutes. So, Jim, when you say we, who do you mean?
You mean the ones for the paleogeography project?
All through your talk, you said we.
Yes.
Who is that? ICS?
No, the people I show on this first slide, some of those, half of those are students, half of them are the geologists who are providing the information and of course doing the graphics. So, and for DDE, that is supported by DDE. They give like 50,000 a year for this project right now, thanks to you too, I think. So we do have the funds to work, for example, in Africa and Asia, where there is not this information. So that doesn't support many people, but realize the students, because they know this is going to come out for the public of the world to use, they get really enthusiastic. And that's what comes into it.
But Jim, ideally, how would this be housed and structured to make sure that it's sustainable indefinitely?
That's a good question. So we've been working on trying to migrate, at least mirror it over to the DDE cloud system, which is then distributed. It would be great if this could be like under UNESCO, so that indeed it becomes a resource under UNESCO, because really this is UNESCO type stuff, the education science for the world. So that would be ideal, that this becomes, and I've been talking to the Commission Geological Map of the World, mainly about collaboration, but perhaps they would be the best ones to host it, because this really is the basic for like the global geology, and would go with their other things. So that would be more long-lived, I think, and permanent. The tricky part is to keep it updated. And that's true of some past databases where when the people involved retire or pass on, the databases go stagnant and they die.
Okay, Jim, let's focus on that. And my question is, could we set up some sort of global website that would cause jurisdictions who deserve to look good look that way, and the reverse? Now, you know, academic research groups can do astounding and inspiring work for a little while. but then they tend to fade away. The agencies that are there forever are geological surveys. And I give full credit to academics, but ideally the Geological Survey Agency for a jurisdiction should maintain the infrastructure that you're describing, national geological surveys and subnational surveys in federal jurisdictions. And if there was some way to give each of those jurisdictions a report card, then you nicely make some of them look good, and you find a way to appropriately make others look not good. That can inspire work. And, you know, a mechanism like that could harness the geological surveys of the world to bring things up to date.
Yes. Envying other ones, say, why can't we be like that? It helps a lot. Yes, in science, right?
It's you know, it's the most effective mechanism. It's way more effective than money. Just instilling rivalries. Oh, that can just change the world. Can I just slip something in? Daniel, what's the difference between a COSUNA profile and a GeoLex entry for the USA?
Well, the COSUNA charts are the actual stratigraphic vertical expression, whereas the GeoLex is like the individual formation entry, if I remember right. So, you know, and it has, you know, so if you go to the GeoLex and you search a formation name, it'll give you, you know, the information about that unit as the USGS has digested it. And then the COSUNA charts are the actual like stratigraphic profiles and correlations between them across the continent, if that's as I understand them.
Yes, generalized.
Beautifully. And Jim, you follow what Daniel is saying.
Yes, because we looked at the COSUNA charts when we paired with our timescale creator packs for the United States. Yes. And that came out as DNAG as well, after we followed the DNAG 1 sets. So, yes.
So if we were to update things for the USA, I don't know who I want to ask first. What should we do?
For the USA? Well,
Yeah.
there, I think then the combination of MacroStrat and the AAPG and then US Geological Survey, that would be the ideal combination. MacroStrat for the technology, how to make it publicly available, which is important because therefore the public supports doing this. And then the Geological Survey for essentially the information, and APG partly on how to make it, again, available to the public. That would be my idea.
Now, Daniel, I'm a great admirer of the University of Wisconsin group. Oh, I'm a tremendous admirer. I'm cheering you on. I'm praising you. I'm admiring you. Now tell me, Daniel, do you expect your arrangements to be there on a permanent basis forever?
Well, no, because I'm actually at George Mason University now. So I finished my PhD. My research was in macrostrat, using it for the Ediacaran period. But I think I know we're running out of time here, but one of the prime products isn't necessarily, I love my research. I love doing research with aggregating rocks and making time volume. But the thing that I think is the longest lived product is Rocked, the app that Jim showed. And the fact that that is a free app that can be downloaded and people can use that to see what is under their feet. Because I think my opinion is that if you can help people figure out what is the heritage on which they sit, like what the foundation of their house is sunk into, right? That would have a lasting impact. And if we can make that the product that people compete, who has the best localized map, you know, geologic map app, because not only Rocked have geologic lithology stuff, but it has fossils that connect to it. It has minerals. People can take pictures, and you know, it can get the community involved, and people who are, as we call, amateurs. I hate that term to refer to people who are fossil or rock enthusiasts, but you know, getting them involved, I think makes these things more eternal.
Cool. Our idea is to go one step beyond what the current one has, and give you not just what's on the surface, but also what's below and what's nearby above. So it's put you in the context of here's what's changed for Earth history. So it's not just what you're standing on or that location, but essentially the bigger scale. And here's what it looked like in the past when it was deposited as well. So yes, that's our dream. And well, yeah, we're halfway there maybe on some of these.
Yeah, thanks all for this very lively and active discussion.